Earlier on I did a couple of videos on bench grinders and how to set them up, and I went on to wood chisels and things like that, and I said I would make a little video on how to grind twist drills. So I'm going to do that now. I think you should have quite a bit of experience in grinding if you get into this stage, so I'll go through it rather quickly because it's quite complicated, and we've only got half an hour to do it in. So here's a twist drill. It's 2932, which means if you add an inch, which is roughly 25 mil, divided into 32 pieces, the thickness of that is 29 parts of a 32. So that's 332 left, is 332 under an inch or whatever. So now then, what I'm going to show you do is to grind a twist drill, and the best thing to do is to show you dry first, and this is the way without using the wheel, and just to give you an example. And the best thing to do also is to use a big drill to start, because you can see more about it. If it's in a big size, then we can go to smaller sizes later on. So here we go. Now then, what we need to do is to regrind that face there. And let's say, for example, that has become rough or whatever, and we want to grind it. What we got to do then is to put it on the stone, either like that or like that, and grind it to the right same size it was when it was new, or the same angles. And before we do that, let's do a dry thing to give you some indication of what I mean. And this is, and I think now I just knocked up a drawing of a drill that is like that there, with those angles there, and that is looking at it endways like that. So let's look at the drawing first. Now then, the drawing here, which is there, is like that, and we'll cover that area first. But before we do that, let's go through the parts of the drill. This is the flute here. You can have fast flutes and slow flutes, and that gives you your rake angle. That's the rake angle there. That's the way that it cuts the metal, and that's quite a slow flute, so it would have quite a shallow rake angle. And also that's the flute, and this little ridge that runs along there is called the land. We call it the land anyway, and that is been relieved there, which means it's been taken out, deliberately been relieved, so that that governs the outside edge of the drill, and that's the most liable to wear away if you're running a drill at too high a speed, because that's the further from the center of the drill, the higher the surface speed. So that's what you get first, and if you were running at too high speed, that would wear away. If you run at too low a speed, it's the center that suffers, because that would prefer a higher speed, and that would prefer a lower speed. But on that, so that's the flute, that's the land, and that here is the web. That's the piece that joins the two cutting edges together, because they're offset. They're not. And that's the piece that joins the two pieces together. That web has been thinned in the past, and we'll cover that later on. We thinned the web. But so there we are. So that's what the parts of a drill you got. Now then, what you want to achieve when you're grinding the drill is to get that angle there somewhere near right. And somewhere near right is 120 degrees. That's that angle there. And we call it the included angle. Included angle. What's the included angle of your drill? 120 degrees, somebody say. 120 degrees is the included angle. That's that angle from that thick line to that thick line. Why I call it included angle? You've got a center line of the drill, and that is the angle there for that edge, and that is the angle there for that edge. So you've got one angle, two angle. If you put the two together, you call it the included angle. And if somebody says included angle, you know what they're talking about. How to get 120 degrees? That's up to you. I mean, it doesn't have to be 120 degrees. Some people say it's got to be 190 degrees. Well, that's a little rubbish for a start. It can be anything between plus 130 degrees, 132 degrees, generally speaking, so that's increasing. The included angle is increasing. 130 degrees. You use 130 degrees with high carbon steel, stainless steel and things like that. And then, so the softer the material you're drilling, generally speaking, the smaller the included angle will be. So you go out to 130 degrees, you go down to, well, the smallest angle I've ground is 70 degrees. So you can see that's quite a long way down. And that was used, well, I had a reason for that, and I might come to that later on and explain why and how I'm doing it, and perhaps we can make a drill at 70 degrees included angle. But for now, we're going to stick to roughly 120 degrees. Why 120 degrees? Well, 320 is going to be 360, which is the degrees in a circle. So that is a third of the circle. It's a nice convenient time. And if somebody said, well, how am I going to achieve that? Somebody and so how am I going to know? Well, I remember somebody telling me, decades and decades ago, they said, well, you get it by looking at that thing on the wall. And what's that? That's the clock. And they say, well, if that's 12 o'clock, that's 4 o'clock, that's 8 o'clock. It's equally distanced. On the center hand part of the where the hands of the clock rotate on is the center point. So if you were to put that on there, it would give you 120 degrees. So when you're looking at the clock, you haven't got to see that in. You know roughly what the angle of 20 past and 22 is. So then you can imagine in your mind's eye, and you can grind that then to roughly right, and that's near enough. When I was driller, tool setting in a factory, you're up against time. On time, you didn't have time to prat about with bits of this and bits of that. You just ground it by what you remember, 120 degrees up. Because if it's 122 or if it's 118 or whatever, it doesn't make a huge bit of difference. So there we go. So long as the angle is right, if it's that there and that's right, is equal on there, then it's not too important. The more important one by far is the web angle. Now that's got to be 120 degrees. Where's the web angle? Well, there's the cutting edge of the drill. There's the cutting edge of the drill, and across there is where the web meets. And you get a ridge across there. When you grind that and you grind that, you get quite a distinct ridge. And that ridge must be very close to, or bang on, 120 degrees. Why? Well, it's got a milling action. That web doesn't cut, it mills. It wears its way through in the spec, but it doesn't wear away. It mills its way through. And therefore, it's quite important. If it's 90 degrees, it will not cut. Because what happens at the back of the milling edge catches the back of the other milling edge, and it just shines it, and it refuses to go. If it's more than 120 degrees to some extent, it gets weak and it wears away. So what I've done, I made a little jig. I shouldn't do it. I said I'm going to do it by hand and eye. I've never done it in the past, but I made it, and I've cut it out of air duct pipe, and I've cut it with a protractor to 120 degrees. And if I put it on there, put that down. We put it on there, then, and put it up on either of them faces, then it will be 120 degrees, and that's what you want to achieve. If I put it on there for that included angle, it will be 120 degrees. And that's a good little thing. You can put one in your toolbox if you like. It's not a bad idea. So what I can do then to just check that, I can put that on there, put it on a face like that, and just run the other face up to that angle. And then when it reaches it, I can have a look at it, and that's pretty good. It's bang on 120 degrees. The other one I want to look at is this way, like that, and that's 120 degrees. I can't check that at the moment, because what has happened is that I picked this out of the drawer, and the web has been thinned quite successfully. That's probably done quite a bit of work. But there's two other cutting edges there. When you thin the web, you reduce the milling action of the web because you make it smaller, and you also introduce another cutting edge. Instead of milling, that edge then cuts, and therefore it's more efficient and more effective. So when you can, and you should every time you can, reduce the web. When you get to some below 2 mil diameter, then it gets a bit difficult to reduce the web by eye anyway. And but beyond that, up to anything you like, up to an inch or so, you can thin the web. You can thin the web every time. Okay, so there we are. So now then, what we want to do is we'll just put this on, and I'll show you what I would do. Now then, if you come here and you want to present the drill, I'm putting it right angles to the stone at the moment. You present it parallel with the ground. Parallel with the ground. It isn't down like that. It isn't up like that. The drill is parallel with the ground. That's important. You got an angle on it, so you rotate it like that. But it's still parallel with the ground at 120 degrees included angle, right? And as well as that, that cutting edge, when it hits the stone, has got to be parallel with the ground with respect to twist. It doesn't got to be like that. It hasn't got to be like that. It's got to be like that. So you've got quite a bit to think about at the start. You've got to be parallel with the ground. You've got to be at the right angle. And you've got to be neither like that, and that's got to be parallel with the ground. Horizontal, if you like. That's got to be horizontal. That's got to be horizontal, and that's got to be horizontal. So you've got quite a bit to think about. Right. So now then we can start to drill. You know what we're talking about. Now then, or start to grind. When you start to grind, the important thing to remember is that a lot of people think that you're not going to relieve that angle. It's going to touch at the back end. If you do like I say now, then I've never found that to occur. And what I'm going to say to you is this. You got that right now. You're parallel with the ground. You rotated it to there. It's neither like now like there. And then you're going to start it. As soon as you hit that stone, you barely dwell. And you start to turn the drill like that. Now then, if you dwell too long, you're going to put a flat on the drill there, and it just will not cut. So as soon as it touches the stone, you start to move the drill. And you come up like that, and like that. And the action is, if you've got a new drill, you can simulate it on a new drill, because you've got a black face and you'll know. But the action is like as if you've got a shovel in a, well actually I described it to me, I remember when I was a kid. It's like putting a shovel in a big chunk of muck, and you're going to chuck it in a trailer with a shovel, and what you do, you twist it up and go like that, don't you? In, throw it up, in, throw it up. That's the same action. In, turn, and up. That then follows that face. You're at that, follows that face. So, we got that far. Now then, we'll do that now. So what I got to do is get that level, parallel with the ground. Because of the angle of the camera, it might not show, but I've got it parallel in all them respects. So if I switch the grinder on now, wait for it to warm up. Now then, what I'm going to do now is present that, as I said, parallel face, because we know that the included angle is right, so it's parallel with that, parallel with the face, horizontal to the ground, come in and starts as soon as you touch the wheel, move it. Touch in, move it. Now they're not assimilated, there's no fresh face on there, it's the same as the bloke that ground that there before. Go to the other side, horizontal, parallel with the drill, as soon as you touch, parallel with the stone, as soon as you touch the stone, you move it. Move in. Alright, now then, the bigger the drill, the longer it stops on the stone, because you've got to remove that much metal. If it's a small drill, it's a quicker action. But you get it right with the big drill first, and the smaller drills are more complicated, and therefore you want to get a big drill right first. So here I go, I'll grind a few now. 1, turn over, 2, turn over, 3, turn over, 4. There we are. Now then, can you see that face? Lovely shiny face. There's no fresh marks on there. It's grinding, it's following the last time that this was ground, it's following it exactly. Now then, I got something to tell you about this. We're keeping that at 120 degrees. The web has got to be at 120 degrees. If you grind like that and you do not put in another action, then that web will eventually reach 90 degrees and it will not cut. And when I say 90 degrees, it's at 90 degrees to the cutting faces. And if it's at 90 degrees to the cutting face, you can put it in the drill, in the machine, it will not cut, because the milling action has been negated for the web. So in order, if you don't twist it, then you will get 90 degrees. So you've got to introduce another action, and this is what it is. When you're doing that there, and you put it on there, and you're coming up there like that, and you've looked at it is 90 degrees instead of 120, what you do is, you're there, and as you're coming up there, as well as turning it like that, you turn it like that. Okay, you've got two actions. Turn it like that, and turn it like that. Quite difficult to get the knack of it correctly. And as you do it, you will find that you can't get it off 90 degrees because you're frightened of twisting it, or you're twisting it too much and it goes too big. But either way around, you've got to get it to 120 degrees. That's more important than included angle in 120 degrees. So I'll show you. You've got to go like that, and you've got to go like that at the same time. So look, so there, I'm there. Now if you notice the hand, this hand will turn. And I don't do that. See that thumb there? I don't do that, but it's a very slight action. It's only a matter of a few degrees of turn. But I don't do it like that. I do it like this. See that thumb is turning? And if I went like that now, it wouldn't have that twist in it. So if you watch my thumb, as I go in there, that's parallel, horizontal and parallel, touching, turning. Horizontal, parallel, touching, turning. As soon as I present that to the wheel, I start to do that action. Okay? Now then, you can grind on the periphery of the wheel, and if you're grinding a lot of metal off, I prefer the periphery of the wheel because you can grind more and it's actually a smoother action. The only trouble is that when you're using the periphery of the wheel, you don't get them same angles right because it's a turn on the stone, and you'll be surprised you don't get the same angles. What I'm going to do to show you on the periphery of the wheel, I'll just move the camera in a little bit. Sorry about knocking it about, but we'll see what happens. But what I'm going to do now is I'm going to just get that about like that. And what I'm going to do, I'm going behind the camera now. It's very awkward for me because I'm too far away from the work. But what I do every time, as I told you in the last thing, on the toe rest, you don't put it on the toe rest. That's not accurate enough. You put your finger on the toe rest, you put it on there, that's in the flute. Get yourself nice and comfortable. That's resting against there to stop you pushing your fingers into the wheel. That's resting there to put your drill on, and then feel comfortable. You got it there. This is parallel with the shaft of the grinder. It's pointing straight at the shaft of the grinder. Get that shadow right. Don't get it like that. Oh, there, right. So you got your included angle right, and then you come to there, and then you turn and twist, turn and twist, turning, twisting. All right. Come back. Turning, twisting. All right, and then once you got that hang of that, you can just go. You went into a workshop. That's what you would expect to hear. Cool your work as soon as any chance we get. You can, if you want to, and you don't want to rotate every time. You can just do this. 1, 2, 3. And then you can come over here and do 3. 1, 2, 3. Save turn every time. But you might get it out there. You might start your to drift, that won't be the same because there's a chance that you'll drift. But you can also go backwards like this. And turn it back. That's if you want to remove a lot of metal. Count them, you see I done 1, 2, 3, 1, 2, 3. So when I was doing that I went backwards. 1, 2, 3, 1, 2, 3. Turn it over. 1, 2, 3, 1, 2, 3. That way, with a bit of luck, you haven't lost your included angle, and the length of each cutting edge will be the same, or ought to be the same. Now then, we can check that. And what I'm going to do now is take you uphill to another area. And this is, here we are, we're up here. That's where my light is, up the top. And you'll notice it's made of this white material that is used for fascia board. I'll turn that off. It's used for fascia board on houses nowadays. And what I've got it for is to hang my lights on, like that, you see. And I've turned that light round now because I want to measure. I want to measure this face now with my rule. I hope you can see that. But I want to measure to make sure that that cutting edge is the same length as that cutting edge. I don't normally avoid that, and I do it without the web being thin because you get it more accurately, and that web wants grinding out. And if I was doing this to put it in the drill, I would grind down them edges until that web, that thinning of the web had disappeared, and start from scratch. But let's say we want to measure those angles now. Now then, what I've done, I put that up like that. Now then, I can remember when, it'll be about 1960 or something like 61. I was sort of tool setting, and one of the guys who've been there for ages, Glyn Evans, I was trying to do that, and he said, what you want is a white face behind your cutting edge to have a look at it. And he said, you go, the white face is on your thumb, and we used to just put our thumb behind, and we could guess it. We can guess it, and I'll show you how to do that a bit later on. But with a big drill, it's better to measure it. So therefore, you want a white face behind so that you can measure that cutting edge. And if you get it bang on, then what you can do is put your drill on the edge. I put it on the 2-inch mark and having a look. And because there's something white behind, I can get a very accurate measurement. If it's dark behind, then you can't. But if you've got white behind, then you can. And that is actually a 1/2 inch. Because it's at an angle, it's greater than half the 332, and it turns out at 1/2 inch. So I turn it over, I put the 2-inch right on the land, and look at where it touches the web. And that's 1/2 inch. So that pretty well is bang on. That drill, the cutting angles are the right angles, and they're at the right length, and so that will work okay. So then I can turn that off, and we go back to the grinder. So that is quite a bit to swallow, okay, and we're running out of time. So having done that, I'll show you, if you've got a smaller drill, sorry about mucking you about, but if you've got a smaller drill, now this is a smaller drill. Now then, as I said to you, it's the same process, but I'm not going to do it on there. The beauty of that is you can safely remove more metal with a big drill on the periphery of the wheel. But I could do it on there if I wanted to, and I probably would. If I wanted to remove a lot of metal, I would do it on there. But I'm back on the side of the drill now. I got to move around the camera all the while. I'm back on the side of the grinder, sorry. And therefore, I can look at that looking at this to start. When you're looking at a drill, you say, is this worth grinding? Are the lands badly worn? If they are, you want to get a grinder and just cut it off with a grinding disc and start again. But look at it, see it's worth. If it is, then you can get on with it. You know roughly now, experience will tell you what 120 degrees looks like. It's good, nice, good average to go on. After the drill, keep that parallel, keep that, not like that, not like that, not like that, not like that. As soon as you start to what you call you grind. Well, what I'm going to do is show you that now we're on a smaller drill. It's a quicker action. Okay, now I'm going to have to do this. I'm going to have to do this in 2 halves because I'm going to run out of time on the camera. You've got enough to get on with now. And the piece there wants grinding away. The land is damaged, so I'll carry on doing this. And so you've got enough to get on with the camera. If I run out of time and it cuts out, then what I'll do is a part 2 on grinding drills, and that'll be regarding thinning the web. But if you do that, I'm turning, twisting and turning. If you look at it now, then it's not on the stone so long because it's got less metal to remove, and so the action is quicker. But it is the same, but quicker. You see, and you got your chance to alter your included angles, because if it was like that and it wants to be like that, when you put it on, you can move it a little bit like that, and you can make the included angle smaller. So if I were to do that, I've introduced a second cut now, just there, and if I go round and I do the same here, and if I do that, then I'll open up that angle. I'll open up that angle and become 118 degrees or 115 degrees, but I don't want it, so we go back to 120 degrees. I know that that is 120 degrees, and if I grind that now, and when I've got them the same, I'll look at that, like that, and I'll say to myself, that angle, the included angle, is less than 120 degrees. I can tell from experience, and so therefore, instead of like that, I will move it a little bit like that. I'll carry on grinding. But when you're doing it, when you decide on that angle, you keep to that angle. And how do you keep it the same? And I'll tell you how I keep it the same. I hope this is still running. When you do that, you do it like that, and you decide your angle. You're looking at the angle. Now then, when you come there, you turn it around, and you don't look at the angle. You just look at the stone, because the old angle influences your eye. You got that against there, and you got your finger against there if you want to, or you've got it running free, whatever. At the moment I haven't got touching. So whatever suits yourself, do that, and that will turn out to be the same. I'm increasing that angle now from about 115 degrees to something approaching 120 degrees. I got to keep grinding on that now, because the angle that I made previously is still just there, and I would grind that till I get it out, and then I would accept it.